Today, we're going to be having a look at continuity and piecewise functions. So the question is, we've now got a problem. We looked at this last one over here. This function is not continuous. Where's the problem? Problem happens right here at x equals 2. The problem is that up here, it is a different value than down here, meaning there's not a smooth transition from one function, the blue function, to the red function. It's a drop, or it could be vice versa, a jump up. A continuous function is any function in which there is a smooth passover between the multiple functions. So we're going to look at a more complicated piecewise function, and we're going to have a look at it and talk about its continuity. But just for a quick definition, in plain speak, a continuous function doesn't have any gaps. So we're going to be having a look at a function, and we're going to have a think about where it is continuous and where it is discontinuous. So let's try and sketch this graph. F of x is equal to negative x while x is less than 0, x plus 1 when x is between the values of 0 and 2, and minus 3x plus 9 when x is greater than 2. So we're going to split this into three pieces. So we're going to have y1 is equal to negative x. We're going to have y2 is equal to x plus 1. And we're going to have y3 is equal to minus 3x plus 9. So we want to sketch this function. So we need a few points for each of these. So let's start off with y1. So y1 is defined when x is less than 0. So there's a few key points we want to choose. We need to choose 0. And then we need to choose other points. That's a key point because it's a changeover spot. It's where one part of the function moves to the next part of the function. But we also need to choose some other ones that fit the definition. So less than 0, so negative 1 and negative 2. So the 3 points we're going to do is negative 2, negative 1, and 0. So let's start with x is equal to negative 2. Well then, y1 is equal to negative 2, commonly known as 2. When x is equal to negative 1, y1 is equal to negative 1, 1. And the last point is when x is equal to 0, y1 is equal to negative 0 or 0. So we've got 3 points, negative 2, 2, negative 1, 1, and 0, 0. So these are 3 points on y1. Let's have a look at y2 now. So for y2 is equal to x plus 1, well, what are the interesting points for this one? Well, let's have a look at its domain. So its domain is between 0 and 2. So the interesting spots are at 0 and 2, and we need to choose probably at least one other. So in this case, I'm going to do 1 as well. So x equals 0, 1, and 2. So x is equal to 0. Well, then y2 is equal to 0 plus 1, or 1. So we have 0, 1 is on the point. X equals 1. We get y2 is equal to 1 plus 1, 2. So we get a second point, 1, 2. And for our third point, x is equal to 2, which is our second changeover spot. We're going to get y2 is equal to 2 plus 1, which is 3. So we get the point 2, 3. Now let's just keep in mind what's going on so far. So these 3 points are going to connect up like this. Why? Because there's no lower bound on y1. There's only an upper bound, and it's a hollow point because it is non-inclusive. For our second one, both of the endpoints at 0 and 2 are both inclusive, and it is going to look like that. And then the third one is going to look a little bit different. Let's just join up the first two, and then we'll worry about red in a moment. So let's set up our axes and get started. Let's start by plotting those points for y1. This is going to be done in black. So our first point was negative 2, 2, negative 1, 1, and then we have a hollow point at the origin. And we can draw these points up together, and we can get y1 right there. y2, on the other hand, starts with a hollow point at 0, 1, and then goes through 1, 2, and then goes through 2, 3, in which there's a solid point at either end, like that and like that. So now all we need to do is to do the red. So let's look at y3. So y3 is defined as negative 3x plus 9 when x is bigger than 2. So where are the interesting places? Well, we need to choose numbers bigger than 2, and we need to choose the changeover point, which is x equals 2. So we're going to get y3 is equal to negative 3 times 2 plus 9. Negative 6 plus 9 is 3. So first point's 2, 3. That's interesting. We'll come back to that in a moment. So 2, 3. X equals 3 is going to be y3 is equal to negative 3x, negative 3 times 3 plus 9, which is negative 9 plus 9, which is 0. So we get 3, 0. And our last point, x equals 4, is going to be y3 is equal to negative 3 times 4 plus 9. Negative 12 plus 9 is negative 3. And so we get our last point, 4, negative 3. And so we've got these 3 points that are all there. But you'll notice the first point there, 2, 3, is at the same spot as our last blue point. So in that case, we don't actually need to draw it because it is already on our axes. So I just fixed up the slightly wonky spot. So the first one there goes just like that. Little, oh, whoops. So it goes over the blue spot. So it actually meets the blue line at x equals 2. The next point is 3, 0. So it's going to be 1, 2, 3 across 0 down, and then 4, negative 3 is the last one. And there is no upper limit, meaning it's going to be this shape. But because it meets, we're not actually going to see it. It's just going to go off like so. And so there is our y1, y2, y3. 3 different pieces all together. Now, we were talking right at the beginning of this, I know it's been 8 minutes ago, but we're talking about continuity. So there is a little gap here between at x equals 0. At x equals 0, there is a gap. There isn't a gap at x equals 2. Notice we're talking about the domains. We're talking only about the x coordinates. At x equals 0, the function is discontinuous. At x equals 2, the function is continuous. So the other thing we could then talk about is about smoothness. How smooth a function is to do with how it would feel if you poked it. If something's discontinuous, though, it can't be smooth because you can't have something smooth if there's chunked anyway, so it doesn't make sense. But we can have a look here where it is continuous at x equals 2 and ask, is it smooth? Now, something smooth would be seamless, meaning that not only would it match the height, meaning there's not a gap, but a smoothness is a higher restriction. And for it to be smooth, it would also have to not be a sharp bend. And as you can see here, the answer is no, as it has a sharp bend. So this would be continuous and not smooth at x equals 2, and it would be discontinuous at x equals 0. So it's a quick introduction into a slightly harder piecewise function, but also into smoothness and continuity, which are going to come up a fair bit. I'll see you in the next one. Goodbye.